Chemistry in context, page 212, 14, chapter 14.5, thermal stability, East African Literature Bureau of Services, East African Literature Bureau of Services, Chemistry, page 212, Chemistry in context, page 212, chapter 14.5, the thermal stability of salts. The stability of the salt N plus X minus solid compound is dependent on both the size of its ions and the charge on these ions. The greater the charge, the stronger will be the attraction between the ions, and the more stable will be N plus X minus solid. The smaller the ions become, the closer they can approach each other in the solid crystal, and thus the more stable is N plus X minus solid compound. Thus, we might expect N plus X minus to become more stable as ionic charge increases or as ionic radius decreases. This is, however, one other very important factor to bear in mind during any discussion of thermal stability. When large anions such as carbonates decompose on heating to form smaller anions such as oxides, the crystal containing the latter will generally be more stable than the carbonate, since the charge density on a small O2 ion will be greater than that on a larger carbonate ion, and the former will be more strongly attracted to the cations in the crystal. Furthermore, the smaller O2 ions can get closer to the cations than the larger carbonate ions. This point has considerable importance in considering the thermal stability of nitrates, carbonates, and hydroxides of the S elements. Nitrates 5. Group 1 nitrates, except lithium nitrate, decompose on heating in the Bunsen flame to form the corresponding nitrates, and nitrates 3 and nitrates which are stable. Sodium nitrate decomposes to sodium nitrite and O2. However, group 2 nitrates and lithium nitrate decompose on heating to form their corresponding oxide. Magnesium nitrate decomposes to magnesium oxide and nitrogen dioxide and half oxygen. Lithium nitrate decomposes to lithium oxide and nitrogen dioxide and a half oxygen. This suggests that the decrease in size from nitrates to nitrates stabilizes the group 1 nitrates to heat, but that the group 2 nitrates can only achieve thermal stability by decomposing from the nitrate to form the much smaller oxide ion. Carbonates. The pattern of the thermal stability among the carbonates is very similar to that of the nitrates. The carbonates of group 1 except lithium carbonate are stable at the temperature of the Bunsen flame, but those of the group 2 decompose at this temperature to form the corresponding oxide. Magnesium carbonate decomposes to magnesium oxide and carbon dioxide. Here again the group 2 compounds are achieving thermal stability by forming their oxide. How do you think the thermal stability of magnesium carbonate will compare with that of barium carbonate? Explain your answer. How do you think the thermal stability of magnesium carbonate will compare with that of barium carbonate? Explain your answer. How do you think the thermal stability of magnesium carbonate will compare with that of barium carbonate? Explain your answer.